Question statement of the process heat transfer problem is the inner and the outer surfaces of a brick wall having a thickness of 30 centimeter with the dimensions of 5 into 6 meters with the thermal conductivity of the wall is 0.69 watt per meter per degree centigrade, and the temperatures of the wall are maintained at 20 degrees centigrade and the 5 degrees centigrade respectively. So you have to determine the rate of heat transfer through the wall in the units of watt. This is all about the question statement. Let's have a look on the dimensions of the wall. So this is a brick wall, and the left side of the wall has a temperature of 20 degrees centigrade, while the right side of the wall has a temperature of 5 degrees centigrade, and the thickness of the wall has approximate value is 30 centimeters as mentioned in the question statement, and the overall dimensions of the wall is 5 into 6 meters. Let's have a look on the solution of this question statement. So the inner and the outer surfaces of a brick wall are maintained at the specified temperatures, and you have to determine the rate of heat transfer through the wall. We'll take few assumptions in order to solve this question statement. That the steady operating conditions exist because the surface temperatures are maintained at the specified constant temperatures. We'll take few assumptions in order to solve this question, that the steady operating conditions exist since the surface temperature of the wall remain constant at the specified value. The second assumption is the thermal properties of the wall are constant. The properties that we are going to use in this problem is the thermal conductivity of the wall, which is mentioned in the question statement. That is represented by K, and which is equivalent to 0.69 watt per meter per degree centigrade. So in the analysis, we have seen that under the steady state conditions that the rate of heat transfer through the wall is given by this formula. So the rate of heat conduction is equal to the thermal conductivity multiplied by the surface area of the wall multiplied by the temperature gradient divided by the thickness of the wall. Let's try to put the values in this formula. So the thermal conductivity, that is 0.69, which is given in the question statement, and this is the dimension, that 5 multiplied by 6 is the area, that becomes the 30 meters square is the area of the wall, and 20 minus 5 degrees centigrade is the temperature gradient, and in the question statement we are given with the 30 centimeter of wall thickness. So we have to convert the centimeter units into meter. When we convert the 30 centimeter into meter, that will be equivalent to 0.3 meters. And after simplifying that, the rate of heat transferred through the wall will be equivalent to 1035 watt, or simply it can be written as 1.035 kilowatt.